Assalamu alaikum. Am I audible to all? Assalamu alaikum. Am I audible to all?
जी सर.
Okay, is the screen visible?
जी सर. Yes sir.
Students are joining, so I'm waiting for them to join and we'll start the class in a minute. Meanwhile, if anybody has any question from the previous lecture that I delivered, you may ask. Okay, what do you remember from the last class? This example of the sequential circuit. Do you remember this? Wake up guys, wake up. इससे पहले कोई क्लास हुई है आपकी या यही पहली क्लास है?
सर यही पहली क्लास.
First class, sir.
That's why I guess you guys are sleeping. Right?
Yes sir.
Wake up, wake up, wake up. This is an important lecture. जाग जाएं, जाग जाएं. Okay. So remember what did we study in the last class? आखिरी क्लास में क्या बात हुई थी?
सर्किट समझे थे सर.
ये sequential circuit, right?
Yes sir.
Okay. So from this sequential circuit, we draw this table. It says that the output depends on the previous output as well, जो कि state कहते हैं हम जिसको. जो आपकी coming output है, जो next state है, वो dependent है on the present state or the previous state, which you may say. From this state table, we make this second form of the state table where A and B are mentioned for each of the X inputs, like for X is equal to 0 and for X is equal to 1. I guess the students that were present in the last class, who was there in the last class when we discussed all these states and all this sequential circuit? Vakas, were you there?
Yes sir, I think I was there.
Okay. Anybody else? Ali Abbas? Hasnan, I guess you were absent, right?
Yes sir, I was.
Okay, so Zoha, I guess Zoha was there. Zoha is sleeping.
No, sir, I was not there.
I'm talking about You have many Zohas in your class, I guess. Zoha or Zoha. Yeah, Zoha Shah, you were there, right? But you're sleeping, I guess. That's why not speaking. Okay. So from this state table, this is basically just for those who were not present in the last class. I'm going to give a little review of what happens over here. So basically, this is a sequential circuit, and this sequential circuit acts in a slightly different manner than the normal circuits. And what is that difference? That difference is that if A is 0 in the previous state and B is 0 in the previous state, and now if you apply a x0, now the output of this x0 is going to be different if x was not 0 and 1 in the previous state. Like this means that the output states of the previous cases affect the next outputs. This table in front of you, this is telling us that the present state or the previous state of A and B was 0 and we applied a 0. We got outputs and the next states 0, 0, 0. We have only the control of this input x. Now, if you see that if the previous output was 1, 0 and we applied a 0 again, now the output is different from the one mentioned over here. So this tells us that the one thing that you have control of is input x, but this input x results in different outputs every time, and that different outputs are because of the present or the previous states present in the circuit. Like this A and B, if this is 0, 0 and we apply a 0, we may get different results. Similarly, if this is 0, 1 and we apply 0, we get different results. So this is about a sequential circuit. It works in a sequence. For example, the example of a counter. If you have seen the tasbihs that are available in the market for the China tasbihs, you remember the button you press and it counts +1, +2, +3, +4. Have you seen it?
Yes. Yes, sir.
So basically that is a sequential circuit. When you push the button, it knows that I'm already on 3, so it goes to 4. When you push the button again, it knows that I'm on 4, so it adds 1 in it and goes to 5. So every time you're going to have a different output, even though you are going to put the same input. Now you get it?
Yes, sir.
Okay. So from this table, this is the state. A0, B0, A0, B1, A1, B0, A1, B1. From these states, we make this state diagram. How is this state diagram made? For all of you who have not been able to attend the last class, I'm going to take another case. And with the help of that case, I'm going to describe the present state and the next state as well, and the state diagram as well. So be very attentive. I want each and everybody to be very attentive. Plus, Hasnan, you should tell in your class that I'm going to take attendance manually today. That is, I'm going to call the attendance. So everybody should be attentive, should be here in the class. Text in your WhatsApp group, tell everybody that they should be available in the class and awake as well. Okay,
sir.
Hasnan. Hasnan, आपने नहीं सोना.
Okay, sir. Got it, sir.
Okay. So this is basically for all of you who have not been able to attend the last class. And for those who have attended, this is going to be the new thing right down there, state diagram. So it says present state is A is equal to 0. So we say that the previous output or the state is 0. What we apply is inputs X and Y. We apply them both to equal to be 0. So X is 0, Y is 0. What is the output that we are going to have over here?
0, sir.
Very good. What is the next input that is going to be from the output to the input of this XOR gate?
0, sir.
Yes. So from this point, you are able to understand that how the previous output is going to change the input. We're going to have a 0 over here. So at 0, 0, if you apply, if at A0, you apply 0, 0, you get the same state A0, right? Now, at the same A is equal to 0, we apply 1, 1. I'll just erase it. If this is 0 and I apply 1, 1, here we'll have 0
0,
and here
0,
and here
0.
0. So for 0 at 1, 1 and for 0 at 0, 0, we get the same output back again. That is 0, 0. Look at this diagram. This 0 over here represents the A. This says that if to this 0, if to this present state 0, you apply a 0, 0, this will give you back the state A equal to 0. Or if at state 0, you apply a 1, 1, this will give you back the state A equal to 0. Is this clear to everyone?
Yes, sir.
I'm going to take another case for you guys. Let's suppose that A was 0 and now we apply 0, 1. 0, 1. What is the output of this XOR gate?
1, 1.
What is the output going to be of this XOR gate?
1, सर ये 0 आएगा आउटपुट पे 1 आएगा.
Now tell me what's going to be the A. What is going to be the A on the next positive edge of the clock?
Sir, 1.
Going to be equal to 1, right? Now
Yes,
get back to this diagram. This says that if to state A equal to 0, you apply a 0, 1. What do you get? You get the 1. Am I right? Is this understood?
yes.
If to the state A equal to 0, you apply the state A, you apply the input xy01. This is xy. You get the state A equal to 1. Similarly, if we apply to the state A equal to 0, the xy equal to 1, 0. So at 1 and 0, what is going to be the output of this XOR gate?
1, 1,
What is the output of this XOR gate now?
1.
So this 0 is going to be equal to 1 again, right? So
Yes,
this
sir.
tells us that if we apply 0, 1 or 1, 0, you get from 0 to 1 shift. Is that right?
Yes, sir.
Is this clear? Any questions till now?
No, sir. Clear.
Anyone having any question till now? Is the state diagram clear?
Yes, sir.
Yes, sir.
I should start taking the names. Bilal, Asfar, Mariam, Maz, Hamna, Hafza, Ifa, Ibtisam, Momin, Mishkat, Nayab, Zarlasht, Zahim. Wake up, guys. I want to listen to you. Please, wake
Yes,
up.
sir.
Yes, sir.
समझ आ रही है?
Yes, sir. Yes, sir.
Okay, okay. I'm going to move to the next example. Let's have a look at this JK flip-flop sequential circuit. In this circuit, you have this state table where the states are now A and B. This is the first state. This is the second state, AB. You have only one input over here, which is X. It is quite similar to the circuit that most of you guys have missed in the last class, this one. So please be very attentive. If A and B are the states and you only have the X input, and we are looking at the cases, now let's see that if A is 0 and B is 0 as well, this is 0 and this is 0 as well. What happens if I apply input 0? What would be the output over here?
1.
Good. What is going to be the input over here?
0.
Good. 1 0 output.
0.
0.
At J and K both equal to 0, what happens at the output A?
Previous, sir.
Yes,
No, sir.
it retains the memory. Is this okay? So it will
Yes.
retain the memory A equal to 0 at the output. What happens over here? You get a J equal to 1, and for this 0
0.
0 0. For J equal to 1 and K equal to 0, this is the set.
1.
So you get B equal to 1. Am I right? So B becomes 1 and A becomes 0. In order to have this table in the form of state table, you can have a look over this. How many states do you see over here? A0, B0, A0, B1, A1, B0, A1, B1. For each of the states, we are looking at two cases: input 0, 1, input 0, 1, input 0, 1, input 0. We are looking at each of the possible cases that can happen in this circuit. Now let's have a case where A is equal to 0 and B is equal to 1. This case, I'll just erase the 0 thing. A is 0 and B is 1 now. And we apply x1. So now x is equal to 1. Okay, so you guys have to help me now. If x is 1, output over here is going to be equal to
0.
a 1 is going to appear over here. What's the input over here?
0.
What's the output over here?
1.
1. What's the input over here?
0.
0.
So at J0, K1, B is going to be equal to
0.
0. What was the previous state of B which was traveling over here? That was
1.
1. 1. So this is 0. And J1, B0 will pass
A1.
A1. So this means that from 1, 0, 0, 1, we travel to 1, 0. Is that right? Add the input 1. Is this okay?
Yes, sir.
Now, how do you represent on the state table? For example, the first case that we looked at, 0, 0, input was 0, and it traveled to the next state, 0, 1. So if you see that the present state is 0, 0, we applied the input x is equal to 0, and it traveled to the state 0, 1. Similarly, we from starting at the present state 0, 1, by applying input 1, we traveled to the state 1, 0. From starting at the state 0, 1, by applying input 1, we reached at the state 1, 0. Is this clear?
Yes, sir. Clear.
Any questions?
Yes, sir. सर
Yes.
सर ये जो हमारे पास डायग्राम है सर, ये ऊपर जो आपने भी शो की थी सर,
Yes.
इससे पहले वाली सर, सर्किट वाली
Yes.
सर, इसमें सर ये क्लॉक का सर फिर क्या मतलब मकसद है यहाँ पे सर? हम इसको यूज ही नहीं कर रहे तो।
This is a really important thing about a sequential circuit. Please be very careful. Please be very attentive. This is a very important question as well. You see that if I erase this, in this previous diagram, when we had state A0, B1, and it shifted to A1, B0. While deciding the outputs of this circuit, I took each and every input of the gates and the JK flip-flops according to this state and this state, like A0, which was the present state, and B1, which is the present state. I moved them here to the AND gates and then decided the new outputs. When I changed the outputs, that is from A0 to A1 and from B1 to B0, I did not change the inputs again. Like I did not make this AND gate 0 and this J0, and I did not change the A0 again. No. Why? Because in this sequential circuit, we are looking at a single positive edge of the clock. A single positive edge of the clock. This single positive edge of the clock means that this will change the outputs only once. So for changing the outputs only once, the first change is going to come from the previous inputs, which is from the previous outputs, A0 and B1. Now a positive edge of the clock occurs and the A changes from 0 to 1 and B changes from 1 to 0. Now we are not going to look at the next positive edge of the clock. That is why our system stops over here, and that is how we get these states. If we are not considering the clock in this system, we are going to have a changed output every microsecond. Like you change the output from 1 to 0 over here, this 0 travels back, this 0 changes the output again, this gets back to 0, this 0 travels back again, this changes the output again, and thus the cycle continues. What is the main thing that is stopping the cycle? What is the main thing that is deciding the states? The main thing that is deciding the states is this clock. This clock is basically controlling the output states that just stop. Stop after you have changed once. I'm not going to give you a second positive edge. If you are going to have a second positive edge, you're going to have a next state. And in this table, we are just considering one shift of a state, that is present state and the next state. If you get another positive edge of the clock, you will get the next to next stage. And similarly, the sequence continues. So the clock has a major role to play over here. If there was no clock, the outputs would have changed abruptly, tremendously, simultaneously. Since we are considering the clock, so only one positive edge of the clock is considered, and we decide the present state and the negative and the next state according to that positive edge of the clock. Is this clear?
Yes, sir.
Yes,
Is this clear to
Sir.
everybody?
yes, sir.
Sir.
So
Yes, sir.
I want to listen people other than Hasnain, Munib, Wakas, Mariam, Abdullah Malik, Asfar, Alishba, Ali Abbas, Alize, Hamna. Are you guys sleeping? Are you guys sleeping?
सर जोहा कह रही है कि उसका माइक काम नहीं कर रहा सर, उसने मैसेज किया.
Okay, Asfar is texting in the chat. He's saying yes, sir. So is that yes, sir, to the sleeping thing? Mic kharab hai. Okay. Okay, guys. So in order to understand that how to make the state table, I'm going to give you an example. How the first thing that you need to look into the truth table is that how many states are available in the truth table. How many possible states are there in total? State number 1, I can call it S0 because A0, B0. S1 because A0, B1. Then we have S2 because A1, B0. Then we have S3 because A1, B1. So how many states in total we have?
4 sir.
Yes. So for these 4 states, we are going to apply input x is equal to 0 and 1 to each and every state. So this means that first of all, we are going to have written 4 states in total, S0, S1, S2, and S3. I'll make 4 circles over here, S0, S1, or S2, and S3. This I would call the state 0, 0. This I would call the state 0, 1. This I would call the state 1, 1. And this I would call the state, the missing state 1, 0. So if to 0, 0, this appears to be a smiley, but that's not a smiley. Okay, if I can make a shape over here. Yeah, that's good. But this is not a smiley. This is just a 0, 0. Okay. To this 0, 0, if we apply input 0, what happens? To this 0, 0, if we apply input 0, what happens? The state changes to A0, B1. Am I right?
Yes, sir.
So to this 0, 0, if I apply input 0, the state changes to 0, 1. What happens if I apply 1 to this? The state reverts back to 0, 0. So I make an arrow from here, turn it back into its head, and write as 1 over here. that if I apply one input to this gets back to 0, 0. Is this right? Is this okay?
Yes, sir.
For each and every state, we are only going to have two outward arrows in this diagram. Why? Because there are only two possibilities for each state. Either the input 0 is being applied to it, or either the input 1 is being applied to it. Is this clear? Is this clear?
Yes, sir.
जी सर
Similarly, to the state 0, 1, if I apply 0 input, it goes to where? Speak up.
1, 1.
1, 1. So at 0, 1, if I apply input 0, it goes to 1, 1. I'm making you help to draw the state diagram with the help of this state table. Similarly to 0, 1, if you apply 1, it goes to 1, 0. So the next outward arrow is for the input 1, which says that it goes to 1, 0. Okay, guys, the meeting time is ending. Join the meeting again. I'm going to have the attendance in the next meeting. So please text in your WhatsApp group that I'm going to have the attendance in next meeting. So everybody should join as soon as possible, those as well who are sleeping in this meeting.